NASA is set to launch the world's most powerful telescope in 2018 in the hope that it will help find alien worlds. But using powerful probes such as the James Webb Telescope could prove ineffective, according to one research group. Instead, they want to launch a swarm of palm-sized satellites that could collect more data on potentially habitable worlds in less time for less money. The tiny satellites are known as CubeSats and usually measure no more than 10 centimeters cubed and with a mass of no more than 1.33 kilograms. The idea has been proposed by Amir Blake, an undergraduate student at Howard University in Washington, D.C. He is studying the possibility of using CubeSat to search for a new planet around the star Beta Pictoris. We wanted to know, are there any other planets other than Beta Pictoris b, and if so, where are they? Blake told Space.com. In 2008, NASA's Hubble telescope spotted a giant planet that was 1.5 times larger than Jupiter orbiting the star. Only 12 million years old, or less than 3/1000ths of the age of the Sun, Beta Pictoris is 75% or more massive than our parent star. It is located about 60 light-years away towards the constellation of Pictor, the Painter, and is one of the best-known examples of a star surrounded by a dusty debris disk. It circles its host star at only 8 times the distance of the Earth and the Sun distance, making it the closest exoplanet to its star ever to be directly imaged. Earlier observations showed a warp of the disk, a secondary inclined disk and comets falling onto the star, all indirect, but telltale signs that strongly suggested the presence of a massive planet. This planet came to be known as Beta Pictoris b and is the closest orbiting exoplanet captured by direct imaging. The technique relies on capturing the light reflected from a planet. But it can only capture large planets. But astronomers believe there may be smaller planets there too. That's where CubeSats come in. Blake says a CubeSat could search for other planets using a process called the transit method. This looks for dips in the brightness of the star as a planet moves between it and Earth. We would definitely be able to see hot Jupiters, Blake told Space.com. We would like to get as small as maybe Neptune-sized planets, but things get more complicated when you get to smaller sizes. The biggest challenge for a CubeSat mission is time, according to Space.com. There must be 3 transits recorded to confirm the status of a planet, and it's not known whether CubeSats capture this detail over that length of time. But Blake says it worth finding out. It would be great to be able to find exoplanets with less material and preferably in quicker time.